We can now do a fairly large amount of work to come up with the empirical formula for a compound, but most of our compounds aren't as simple as the empirical formula. Molecules will often have a molecular formula or a count of the total actual atoms in the molecule that differs from that empirical formula. This video will illustrate the relationship between the two. Now, as a reminder, the empirical formula is the smallest whole number ratio of the atoms in a compound. The subscripts in an empirical formula cannot be reduced any further. Here are some examples of common empirical formulas. Now, the limitation of that empirical formula is that it just represents the ratio of atoms in a compound and will not always represent the actual count or what you actually have sitting in front of you molecule-wise, especially when your empirical formula doesn't really make all that much sense chemically all by its onesie. Now, often the actual atom count will be given by the molecular formula and not by that empirical formula. Atoms in both the empirical and molecular formulas will be present in the same ratio, but the molecular formula will be some whole number multiple of that empirical formula. Now take the empirical formula CH2O, for instance. This empirical formula represents a possible and very real molecule, but many more molecules that are multiples of this formula also exist. Notice that in all 5 of these formulas, the ratio of the atoms is 1 carbon to 2 hydrogens to 1 oxygen, regardless of the total atom count. So all 5 of these molecular formulas represent different molecules that share a common empirical formula. So how do you move from the empirical to the molecular formula? Well, you need an additional piece of information that describes your molecule, and that's the molar mass. Since the molar mass is the sum of the masses of all of the atoms in a compound, we can use it to work towards the molecular formula for a compound. Now, generally, you're first going to have to determine the molecular formula for your compound, just like you did in the last subsection. Next, you'll calculate the mass of the atoms in that empirical formula. Now, this might be referred to as the empirical formula mass or the molar mass of the empirical formula, or a number of other things that sound similar and are related. What you're doing in this step is figuring out a measurable quantity related to the building block of your molecule. You'll need both the molar mass of the compound and the mass of the empirical formula to determine the number of formula units that make up your molecular formula. This will be a whole number, and you'll multiply all of your subscripts in your empirical formula by this multiple. Once you do that, you'll be able to report your molecular formula. Now let's practice. Let's say that our chemist is trying to characterize a compound. They've determined that the molecular weight of the compound is 176.12 grams per mole, and they've done all of the empirical formula work for us, and they've determined that the empirical formula for their compound is C3H4O3. Now, our first step is to make sure that the empirical formula isn't also the molecular formula, which we can do by comparing the molar mass of the empirical formula to the molar mass of the molecule. 3 carbon, 4 hydrogen, and 3 oxygen will give us a mass of 88.06 grams per mole. Since these two masses are not the same, I know that my molecular formula has to be different than my empirical formula. So on to calculating the number of empirical formulas that I need to make up that molecular formula. To do this, we take the molar mass of the molecule, the bigger of our two values, and divide it by the smaller of our two values, or the mass of that empirical formula. When we do this, we get a value of 2. This 2 means that there are twice as many atoms as there are in the empirical formula in that molecular formula. Now in practice, you'll multiply the subscripts in your empirical formula by this value that you just calculated. Doing so will move you towards the molecular formula.